We have supplied some average weights, and it would be useful if the farmer actually supplies exact weights if they're available for these categories. For the lambs, effectively the calculation goes on the amount of growth that they've put on, so they have initial body weight, that's body weight at birth, and a final body weight which either may be at 1 year old or at the time of that lamb goes off the farm for slaughter. So basically the calculation is done on the weight gain and the energy required for that weight gain during the period of the lifetime of the lamb. Again, you might well want to alter that so that you have lambs only born in March and say sold off in November. The total weight gain of all suckled lambs, this is really to estimate the milk production of the ewe, because the ewe will have energy required to produce milk, and this is the total weight gain of all the lambs, not just of a single lamb. So if the ewe has triples, then we're saying that all 3 lambs combined have put on 45 kilograms over the period. Animal wool production, again, this is to estimate the energy required to produce wool, and here we're looking at the number of ewes with single lambs, with twin lambs, and with triplets. Further down again we have times of the animal fed on flat pasture, on hill pasture, or in housing. Digestibility of the feed, there are values available here. Government suggests that you have 75 to 85% digestibility for high concentrate diets, 55 to 75% for pasture, 45 to 55% for low quality forage. Again, the farmer has the choice of entering the value there. Returning to the waste management systems, we have in this case all the animals on flat pasture, so we have basically all the manure is deposited by the sheep on the pasture. If we put some of these animals into housing for, say, some of the time, we have to alter that, 20% and 80%. Obviously, again, we also have to alter this entry here, and for the sheep we might well be using farmyard manure. If you're using farmyard manure or some of the deep bedding systems, the nitrogen content of the bedding is an important component, and again we're using 4 kilograms of nitrogen per animal per year. Store the herd and go back to the control panel. Now we're going to produce a report with this data, and I'm just going to label that custom, create the report. We are already chosen to have all gases, but it is reminding us that this will remove 1 credit from the account. We have a list of all the reports created here. Custom report. Click on that. This time we have more information because as well as the CO2, we have methane emissions and N2O emissions. Then we have the CO2 equivalents, which are reported in the simplified report we looked at last time, and we have the carbon equivalents, which we reported in the V0 calculator. Grid electricity here has 7.47 tons of CO2 emitted. Notice here there's no apparent emission of CH4 and N2O, but there are actually small emissions. They're quite small, less than 0.001. However, when you take the greenhouse gas warming potential, you discover that the CO2 equivalent 7.52 is a bit bigger than the actual CO2 emission, and the difference between 7.52 here and the 7.47 there is related to the emissions of methane and nitrous oxide. The bottom of the column we total for the individual gases and give lower and upper bounds for these emissions, and over here we see that again for energy 13.18 C equivalent and a relatively small bound from 13.04 from 13.32 because we know the energy categories fairly well. Having put in the custom livestock, the rows here just reflect the entries that you've had animals in. The group is the name that you gave to your particular herd. And here we have almost no CO, well, we have zero CO2 emissions, but we have emissions of methane and of nitrous oxide. And again, we sum these up to a group total. So for your cattle herd, 172 animals in total, and the emissions or carbon dioxide equivalent of 560 tons, carbon equivalent of 150 tons. Bounds here though are much wider, so the 560 tons lower bound is 300, upper bound is 950 tons. We sum all the emissions for livestock at the total of this output table, and again we go down to the total at the bottom through all the other categories, and if I again expand this a little bit so you can see it, we have a net sequestration in this farm caused by a large amount of forestry. The total livestock emissions calculated using the custom livestock will be slightly different from those generated by the standard UK data. If you had exactly the same weights of cows and exactly the same assumptions of behaviour and of waste management, you would get the same value. But it's quite difficult to work backwards from the data in the UK inventory to identify the exact values used. So generally speaking, the standard IPCC 2006 calculations give very slightly higher total livestock emissions than the UK ones. However, the important thing is to use the same value. So if you're going to change the manure system, keep to the same estimate. So if you change the manure from, say, pasture to an anaerobic digester, you will get a different emission of methane and N2O. And if you compare these, you will see the gain that you would make by using that particular manure management. Say these tables can be printed, stored for use in the future, and you may then want to go back to the mitigation part of the website. I think that concludes this particular introductory tour. Thank you.